Innovation and Design Thinking. IDT. Module 2. Tools for Design Thinking. Case Study. Physicality in Distributed Design Collaboration. By J. Babu. Tools for Design Thinking. Physicality in Distributed Design Collaboration. How embodiment and gesture can re-establish rapport and support better design? A research work by David Serkin, Stanford University, Center for Design Research, USA. Geographically dispersed design teams encounter challenges to efficient collaboration that are difficult to overcome with present communication tools. The exclusive tangible presence of different individuals within the team working space, the explicitly and implicitly body language signals that they exchange, and the ability to point to and act on artifacts in a shared context are all important aspects or building blocks of effective, physically collocated interaction. These give the social and contextual cues necessary for free-flowing, creative conversations. When teams are dispersed, however, many, if not all, of these capabilities are lost. To re-establish them, authors are integrating expressive, teleoperated robotic avatars into designers' workflows to give remote team members a physical and social presence. Moving forward, the author's investigations will concentrate on using tangible avatars when design process is most physical or tangible during conceptual development, which occurs largely before ideas can be articulated with precision, and prototype development, which occurs after a verbal or written exchange of ideas. Scenario: Remote collaborators. See the figure. Figure shows a small collocated team works on a paper prototype of a remote controller. Philip, a California-based design engineer, is working on a novel remote control prototype. He is now working on the look and feel of an early version handmade paper model in his design loft. Becky, his teammate at an adjacent table, notices him turning to face her to ask a question with a brief glance over. She also turns to face him and asks, "What's up?" before he has a chance to respond. "I'm still figuring out how to make this part feel right, and I'm not sure how well this button position works." "You mean right here?" she asks, pointing to the markings he's made on the white paper box's side, which are framed with tape and wood dowels. "I can't tell if you can reach it because my hands are larger than yours." Becky gently touches the delicate model and responds, "It should be farther this way," and much larger, as she adds new markings to the box in a slightly different location than the existing ones. Philip asks, "How about over here?" as he draws a new mark on the diagonal between the two that currently exist. "Yes, it now works for both of us," she responds as she hands it over and returns to her work. Philip and Becky have booked a video conference with Malte, a colleague in Luleå, Sweden, the following day. Because of their time zones, Philip and Becky have to meet early in the morning, and Malte has to meet late in the evening, but today's schedule works for all three of them. Philip begins by demonstrating their prototype to Malte, or rather, the laptop video camera that Malte sees through. "Are that where you are putting the buttons?" Malte wonders as he observes the markings on the sides. "Yes, Becky and I agreed that the middle one would be better for the majority of people's hands." Malte makes a face, but Philip has trouble deciphering what it means through the screen. Malte's picture is little, much smaller than it would be in person, and the video conference window on Philip's laptop is one of several that are visible. The others contain sketches for the next version of the prototype and a document they are co-authoring. "Could you shift it to the side a little more?" he says. Philip is unsure if he means to move the button to the side of the box, and if so, which side or to move the box to the side of the table so Malte can see it better. So he inquires. He responds, both, really. However, I was referring to the button in particular. I have a prototype with the button positioned slightly to the side of yours. See. Through the screen, he shows Philip and Becky his prototype, which appears to be larger and more refined than the one Philip is working on. Because they can't put both models next to each other, they are having trouble comparing button locations and box sizes. Perhaps we could take measurements of our prototypes and email them to each other for comparison. Malte does not have a measuring device nearby, so they all arrange to meet again later in the day. Constituents of design communication. The first encounter in the above situation was brief, efficient, and arguably more productive, at least in the short term, than the second. Some of the distinctions between these two situations are: physical proximity between teams allowed teammates to interact on the spur of the moment during the first collocated session, exactly when Philip needed assistance. Each teammate could tell when the other was ready to act or talk, and they could predict what would happen next. For simple reference, they both employed demonstrative terms like here and this, as well as pointing, which served as an index into their shared contextual frame. The second distributed meeting, on the other hand, had the topic planned ahead of time, so members met whether they needed assistance right away or not. Philip and Becky had a hard time deducing what the faraway partner meant from what he said or gestured at. Participants fumbled through or chose not to use the comparisons, demonstratives, and pointing that had worked so well when they were collocated because their common frame of reference was gone. Such communication elements aid participants in establishing and maintaining the common ground, the coordinated, reciprocal understanding between what speakers say and what addressees grasp, that is so important in engaging and fruitful interactions. That is, our physicality matters, and its advantages are difficult to secure when separated by a distance. A hierarchy can be drawn between the components of design communication and their attainment. The first level represents the interaction's ultimate aim or rationale. The reason could be to better designs or designers' understanding in the broadest sense. It could be to enlist the help of an expert or to create a cross-cultural perspective in the case of long-distance conversations. Design sessions that take on a tenor of coordination rather than cooperation are symptoms of these aims not being accomplished, as are engineers' feelings that their time is spent in meetings rather than on design tasks. The participants' communication intent is represented at the second level. That is, what they hope to convey, learn, or resolve during the meeting. Participants with uncertain purpose may have differing interpretations of remarks, thoughts, or events, possibly without even realizing it at the time. Cultural differences, as well as a lack of a shared physical setting or common ground, are factors. The precise aspects that contribute to clarity and expressivity make up the third level. These factors include participants' closeness and orientation to one another, as well as their posture, bodily gestures, and motions, and facial expressions. Designers who are unable to articulate themselves or connect with one another, or who believe that they or their partners are alienated from the discourse, are signs of a lack of clarity. At the third level, participants can directly affect change by developing a sensitivity to their own and others' physical presence and gestures. These activities have an impact on their ability to detect context, discuss ideas, and negotiate details at the second level. And these skills help to achieve the first level objectives of effective working sessions and improved comprehension. Understanding collaboration in design. Designers use their bodies. In a collaborative design session, what exactly happens? Designers use their body as a vital component of their work, in addition to the verbal aspects of working together, such as conversing, asking questions, and discussing plans. At first, the hands-on nature of design work comes to mind: how designers engage with physical objects. Designers use their body for communication, both with others and with themselves, in addition to sketching, creating, manipulating, and typing away at keyboards. Designers' skills to sense their local situation, express themselves, and exchange ideas are heavily influenced by nonverbal components of collaboration. Facial expressions, visual gaze, posture, gestures, and other bodily motions are examples of nonverbal communication. Many of these signals can be subdivided further to provide more specific actions. Bodily movement includes pointing at or positioning items, as well as pantomiming observed or intended activities. When one person, who acts them out, influences another, who perceives them, these signals create communication. Explicit signals are those that are at the foreground of the communicator's awareness, indicating that the expression is intended. Implicit signals, on the other hand, operate in the background of consciousness. Depending on the situation, most signaling behaviors can be either explicit or implicit. So a person's surprise expression could be part of a tale, for example, displaying how a user could react to a new remote control, or it could be a genuine emotional reaction to being shocked. Both, however, contribute to the participants' shared frame or common ground. When working and meeting in person, design colleagues take use of each other's proximity. They typically rely on impromptu, unstructured interactions with people who chance to be nearby and available. Participants elicit input, confer on alternatives, and raise and resolve questions during these sessions, which are brief, focused, and content-rich. They occur in local work locations, frequently near whiteboards. Many R&D collaborations would not arise or would fail before becoming effective if such casual sessions, mediated by physical closeness, were not available. As a result, the manner in which designers use their bodies and draw on nearby coworkers contribute to and encourage intuitive and creative exchanges among collocated teams. Similarly, the lack of these assets makes it difficult for distant teams to collaborate on design. Design at a distance. Designers rely on the usage of mediating communication technologies rather than their bodies to engage with each other as design and engineering practice becomes more global, either to draw on the expertise of distant colleagues or to interact with coworkers who are traveling. Voice and video conferencing, email and instant messaging, and shared access to digitized sketches, papers, and models are among the mediators. However, rather than enabling designers to use their bodies, these technologies that attempt to bridge the gap between them rather disable them. Two-dimensional video portals condense their representations to a few square inches on displays that are frequently shared with others, as well as programs and documents. Their facial expressions aren't as expressive as they used to be. They make gestures with their arms and point with their fingers, but they are unable to enter the location they are referring to. Because their position and perspective are determined by someone else within the local center of team activity, they are unable to follow local action. Their vision, hearing, and voice may be dispersed throughout the room on various devices. Collaborators who are too far away become phantoms. Distributed teams schedule meetings ahead of time to guarantee that participants are available. Members' motives for meeting are, on the other hand, rarely predetermined and arise on the spur of the moment. The traditional approach to design activity becomes infeasible at a distance because these non-routine and ambiguous tasks, which rely on direct physical engagement and quick access to collaborators, are impossible to carry out with present technologies. Modes of communication. There are various options for how collaborators can communicate with one another. Each method has distinguishing features that make it better suited to specific types of social discourse and mediating technology. See the figure. Figure shows 4 modes of communication that we see design practitioners employ during collocated and dispersed sessions, expanding on Nass and Mason's 3 modes of analysis for organizational communication. One participant speaks with only one other in the first pane, called one-to-one. An active, co-present design task, or a face-to-face or telephone chat are examples. One participant communicates with a small or large group of individuals in the second pane, known as one-to-many. A lecture or presentation, or a group meeting with a single remote participant are examples. One group communicates with another on the third pane, known as many-to-many. This can happen when 2 teams communicate with one another, either in person if they are collocated or via audio or video conference if they are not. Each of the first 3 modes can occur among members who are close together or far apart, and there is only one channel connecting the individuals or groups at each end of the connection in each scenario. In the fourth pane, known as one-to-many, a single collocated group is joined by 1 to several individual participants, each of whom is located in a different place. This is a satellite communication arrangement that may also incorporate direct backchannel connections between distant players. The satellite configuration is typically used by distant teams, and it necessitates the involvement of one or more support employees to manage technology, such as displays, cameras, microphones, and audio mixers, as well as to moderate the remote discussion. Email, instant messaging, voice, and video chat are all options for back-channel communication. Explorations in distributed design. Authors used a design research approach to investigate the challenges surrounding physicality in design activity by using a number of technological probes. 3 research on the functions of embodiment and presence, agency and approachability, and gesture and expressivity are described here. Study 1. Embodiment and presence. Even the best technologies have difficulty supporting the physical interaction requirements of design engineering sessions. While PC or laptop video chat suits close proximity one-to-one conversations and high-definition video conference rooms suit many-to-many teams, even the best technologies have difficulty supporting the physical interaction requirements of design engineering sessions. Because cameras and microphones are set up for up-close use, video chat suffers when room arrangement necessitates a gap between local participants and those joining remotely. However, remote participants frequently require access to whiteboards or video screens as well as the ability to hear local participants across the room. Video conferencing solutions, on the other hand, alter the way many individuals in different locations are represented locally. Each is bound within a window that shares the screen with other individuals within windows. As a result, the feeling of individual presence and persona, as are distinct and individually addressable physical bodies, bestow fades. Distant individuals are sensory handicapped in various respects, and they share this trait with one another. Authors have started developing and employing physically present, embodied, gesturing avatars at the local hub of design activity to satisfy these specific needs. An avatar is a physical depiction of a person. These avatars, which function as their stand-ins during team interactions, are inhabited and teleoperated by distant partners. Physical avatars provide distant actors a seat at the table by filling the gaps between what they see and how they are seen, as well as what they can do in their own surroundings and in the hub workspace. What impact does a constant presence have on group activities, but also mutual awareness? Weekly meetings of dispersed design scientific community have witnessed a rising number of global members over the last 2 years, producing what we now call a one-to-one-to-many configuration. The fact that these gatherings are divided into 3 forms of social interchange is notable. The sessions start with informal socializing, progress to a more formal organized presentation, and end with a quasi-dynamic question and answer dialogue. As a result of these changes, remote members, and also their local counterparts, take on a variety of responsibilities in situations ranging between close-up individual chat to overhead presentation to room-scale group debate. The local group first viewed remote participants as either passive spectators lurking on the outskirts of action or visible collaborators who required great effort to incorporate in the conversation. The local group was hardly aware of their existence from the standpoint of the remote participant. See the figure. Authors discovered that introducing and arranging distinct physical avatars, as shown in figure, so that local and remote participants could see and interact with each other increased their perceived sense of each other's physical and social presence, and that this increased visibility led to more frequent and on-topic interactions. Perhaps unsurprisingly, the avatar's sensation of presence was most powerful during close-up, informal conversations, when the dialogue may grow more in-depth and rich material might develop. It was vital to present oneself as a distinct individual at the time. Authors then set about offering each remote player with additional possibilities given by their newfound physicality, now that their embodiments have joined in the local realm. A mannequin arm and hand, which could be lifted when someone wanted to join in on the conversation, was one of the most notable of these. However, authors were astonished to discover that few people raised their hands. In trying to figure out why this is the case, authors discovered that it is not the group's social convention to raise hands and request to speak up. Instead, one simply speaks up. However, because to the low resolution capabilities of their avatars, distant participants had limited ability to see and hear. As a result, they'd miss out on some of the local group's action. Because of the consequent ambiguity, many were hesitant to speak up for fear of interrupting other speakers who could not be seen or heard. Study to agency and approachability. Authors moved to a more public location and focused on agency, the attribution of action to individual actors, to better understand how body and motion might serve as markers of a propensity to engage others and stimulate connection. See the figure. Authors designed an interactive touchscreen information kiosk with either a virtual or physically attached gesturing appendage in the form of a waving arm. For the pilot study, the virtual representation was exhibited directly on the information screen, and for the follow-up, it was back-projected onto an opaque vertical screen. The physical arm was attached in a position that as closely as possible matched the expected location. A graphic arrow pointing down toward the kiosk or a human-like mannequin hand was at the end of the arm. This setup allowed us to experiment with different situations, such as virtual versus physical in one scenario and graphic versus human-like in the other, to see how they affected people's behavior. They placed the device in 3 semi-public spots at our research institution so that people passing by could see it clearly and consistently. It was discovered that when passers-by saw a physical arm rather than an on-screen arm, twice as many approached and engaged with the kiosk, and 60% more interacted when they saw a physical arm rather than a projected arm. However, the arrow condition created slightly more interactions than the hand condition, contrary to authors' predictions. The arrow, according to interviewees, was more intelligible than the hand. While this finding does not imply that graphic components should always be favored over human-like ones, it does imply that human likeness is not essential to successfully signal the availability of a communication device for engagement. The results of the interviews also imply that greater human similarity necessitates more careful design. People have preconceived notions about how human arms and hands should look and move. If a robot arm appears to be human-like but fails to perform as expected, people will notice. People have little, if any, expectations of how graphic elements should move. By eliminating human similarity, the physical avatar designer has more freedom in creating the behavior of remotely actuated elements. Study 3. Gesture and Identity. People treat communication technologies as social actors, whether or not they are conscious of it, according to Reeves and Nass in their book The Media Equation. They are courteous, reciprocate, and behave as though computers are their teammates. So, to what extent do the motions and gestures of a physical avatar functioning as a go-between between colleagues improve or perhaps complicate their interactions? And when we look at both explicit and implicit signals, do we see the same social actor behaviors? Authors did a video research right now to see how people interpret different avatar motions. The study's immediate goal is to figure out how these gestures map onto the remote operator's communicative intent. With this knowledge, authors provided visual clues to accompany these intents, allowing users to recognize familiar acts or nuanced expressions while interacting with avatars. Should the avatar depict the state of a faraway teammate if she becomes confused, and if so, how? The longer-term goal is to use this knowledge to the creation of collaborative tools and venues. Some motions appear to correspond to specific behaviors. We shift our heads and sometimes our entire bodies to look to the left or right, or lean forward and down to investigate a feature on a table more attentively, or we instinctively shudder when we laugh. There may be no direct translations for other gestures. How would we show that a distant teammate is perplexed, thinking for a beat, or just present and alert, without appearing idle and dead, or without her avatar being uninhabited? When you consider your own experiences, you'll notice that, unlike computers, individuals don't normally sit absolutely motionless for minutes, or even seconds at a time. Their eyes roam the room, their chests rise and fall as they breathe, and they shuffle their shoes. Authors are starting to look into how remote participant teleoperated inputs should be matched to robotic avatar motion outputs, specifically, when direct mappings should be used and when indirect mappings should be used. For example, in many Indian cultures, shaking one's head from side to signify agreement is normal, yet in the United States, this gesture is viewed as disapproval. With this knowledge, an avatar may do cultural translation, turning a participant's head shakes on one side of a dialogue to head nods on the other. Authors anticipate that such behaviors will have an impact on the avatar's perceived sociability as well as the clarity of conversations. See the figure. Figure shows avatar gestures. In this sequence of frames taken from a video shown to study subjects, a distant collaborator leans in toward the camera and peers into the local space, while the avatar screen moves forward and down, mirroring his actions. The sequence and timing differences between the images shown on screen and motions of the screen itself influence whether study participants interpret the observed action as being controlled by the collaborator or by the avatar. Authors captured head and shoulders films of male and female collaborators interacting through an avatar that can move its own head and shoulders for our initial exploration of these mappings. The collaborators acted as if they were in the middle of a normal chat or working session. For example, they shifted their gaze to the left or right, moved in closer for a better look, nodded or shook their heads to agree or disagree, and exhibited surprise or disinterest. The twist is that in one case, the collaborator gestured while the screen remained motionless. In another, the collaborator maintained a neutral expression while the screen made motions similar to those made by the collaborator previously. And in yet another, the collaborator and avatar made the same gesture in unison. Authors then displayed the movies to the participants in the study and asked them to explain what was going on and what, if anything, was being communicated. See the figure. Figure shows a robotic avatar at work. On the left is a robotic avatar in use during a design session. On the right is a closer view of its remotely controlled components. The remote participant who operates the robot uses on-screen buttons to make pre-programmed movements, such as wave or point near emphatically with its arm, and a handheld gesture-based controller to make front-to-back, left-to-right and tip-up or tip-down motions with its head, which includes a video screen, camera and microphone. So far, the data indicate that research participants have differing perspectives on the collaborator and avatar's individual identities. That is, some of them perceive what they observe as the behaviors of two distinct people, while others only recognize one of the two, and still others conflate identities, failing to discriminate between the two. As a result, participants interpret differences in sequence or timing between the collaborators' expressions and the avatar's motions differently. As a result, if the avatar's motion precedes that of the collaborator, participants may interpret what they observe as the avatar initiating the action rather than the reverse, as is the case. Authors predict that in the future, either the collaborator's expressions or the avatar's motions will be adequate to transmit less ambiguous messages, such as nodding or glancing to the side, but neither will be sufficient to reliably convey deeper messages, such as thinking or boredom. Authors do expect that some combination of them will succeed. Authors' plans and issues for the future. Authors' next research will focus on developing more durable, field-tested avatars for use in working design teams. Authors foresee their utility in particular during concept development, which occurs mostly before either broad design ideas or detailed details can be expressed with accuracy, and prototype development, which occurs after the team, coaches, and management have verbally exchanged ideas and deliberated. This will allow us to transition our focus from proof of concept to implementation with users who have real-time demands, as well as learning how to engage a robotic dialogue mediator on both sides of a global debate. 3 factors stand out as crucial to long-term usability for distant avatar operators. To enable straightforward control and an usable variety of expression, the first step is to build tactile and viewable user interfaces. Video image recognition, which allows either facial expressions or physical gestures to be used as input controllers, and tabletop or handheld devices that replicate the avatar's range of motion are examples of enabling technologies for control. Second, there are ways to improve sensory capacities so that distant participants can see, hear, and comprehend action in the local team hub, and to immerse them more fully in that action. The employment of higher resolution, zooming video cameras on board avatars, as well as sensitive directional microphones, is the initial component of this. The second half allows for alternate inputs like as force feedback tactile sensors, which alert operators when another person or object comes into contact with the avatar, or proximity sensors, which alert operators when they are near tables or walls, for example. Understanding the issues of avatar expansion or inhabitation is the third step. Extension refers to an operator's perception of the avatar as a part of himself rather than a teleoperated object. Greater extension is good if it improves the interaction, but only if it does not compromise the operator's sense of self. For example, we haven't decided whether physical avatars should be identified separately from the remote player who controls them. Authors hope to learn whether people prefer to pronounce multi or avatar multi, or something else entirely, by observing teams utilizing avatars. The questions for the local hub team connecting with one or more distant participants via these avatars are about what makes a robotic presence pleasant to be around on a regular basis. The transparency of the avatar is important for the local team, just as extension is important for distant operators. A transparent interface allows the avatar's appearance to fade into the background, leaving only the awareness of the distant collaborator it represents. How the team will react if or when more than single person inhabits the same avatar at various times, or if more than one person appears on the screen at the same moment, is a potential difficulty. Individual contributors' avatars might be matched one-to-one, or avatars could be customized for each user. Conclusion of this study. Designers work not only with their heads, but also with their bodies and senses, posing a barrier to their usage of sensory-deficient computers. Physical avatars may be able to fill the sensory gap that currently exists between worldwide collaborators. Physical avatars provide a means via which designers may establish their presence and communicate more directly, rather than filtering design communication through a variety of technology portals. Thanks for watching. Comment for any suggestions. Like, share and subscribe for more videos.